There we go. All right. Hello, everyone. My name is Bradley. Most of you probably know me by now.
And my name's Fred. Probably not a lot of you guys know me, if I'm being honest. And yeah, so who are we? I'm a fourth year CSEC student. I mainly focus with the backend web dev, and I can write a working front end, but it won't be pretty. But I get a good backend. I go to RITSEC physical security interest groups on Mondays from 11 to 12 in Golisano, 17:30 when I get the chance to.
Hi, I'm Bradley. I'm a first-year CSEC major. I've been doing mostly front-end web dev for about 4 years now. I do also do full-stack development. I'm also a RITSEC enthusiast. I go to all the things. Please come to Hack Night Tuesdays, 8 to 10 p.m. I want to meet every one of you. Thank you. So, so web basics. All right, there was a presentation last semester, Intro to Web. Go watch it on YouTube if you want to catch up. And this is just a brief overview of what we went over. So HTML, CSS, they're the foundations of the web. Just the programming language that your browser understands and knows how to display web pages using that. Everything is transmitted over the web via something called HTTP, or Hypertext Transfer Protocol. So that's how we transmit HTML, CSS, pretty much everything. It can be used for more than just web, but just we're staying basic here. So runs on port 80, and 443 is a special one for HTTPS. It's probably something you see in your browser. When your browser displays the little lock icon, that means your traffic is secured. That gets a little more complicated. So then, in order to interface with a web server, we use different HTTP methods. So the typical methods are what are called CRUD methods. So this is how you interact with a standard web API. So they stand for create, read, update, and delete. And these are done through their respective post, get, put, and delete methods. If you were to go into Chrome DevTools, you can go to the Network tab, and you can see all these things happen. The URLs they're going to, and what kind of methods they are, etc. We'll get a little bit more into that on a later slide. There are also a few other ones to mention, such as options, patch, head, trace, connect. I think that's all of them. Some of them are barely used ever, and things like options we'll see later. JavaScript. This is pretty much what I've been doing for the past 4 years. It's a client-side scripting language. It runs in your browser. So Chrome has a JavaScript engine called V8, which you can now, and for the past while, you can run JavaScript server-side using Node.js, which is also run on Chrome's V8 engine. So this is essentially how you get code to interact with web pages and make them dynamic. You can use the JS DOM API, and through this, we can manipulate and grab values or modify values from form inputs. We can interact with web cookies. We can do a ton of more stuff with JavaScript. The Mozilla Developer Network, which is sadly been shut down, but I think people are still trying to maintain it, covers all of this in very thorough depth. You can look at that for more APIs. But now JavaScript kind of blew up over the past few years, and it's now everywhere. Like I said earlier, it's on the server with Node.js. We have it on mobile now through things like React Native, Ionic. There's a bunch more frameworks. This allows you to compile native apps for phones that will run your web page as if it were an app. It's really super cool. For desktop, you have things like Angular, React.js. Those are the two primary things I've been using. Things like Vue.js. There's a ton of different things out there at this point, as JavaScript is a very easy language to learn. And so that way anybody can get into web programming. So there's a few vulnerabilities that go along with having JavaScript on your web page. So there's cross-site scripting. That's a big topic. I decided to briefly cover it here with a few topics. So something I see a lot on web is for anything that's interactive that is going to run your JavaScript code. If you have code inputs on a web page, they're primarily using the eval function in JavaScript. Now this is really dangerous because basically it will execute your JavaScript code and you can make HTTP requests, which we'll talk a little bit more later, from that web page using this vulnerability. Also, through JavaScript, we can look at people's cookies. Now, this is used for things like sessions and user IDs and a lot of sensitive information that your browser will store in the background without you even knowing. If you ever go to a website and you hit remember me, well, that's storing a cookie on your browser. So we can interact with those, and that's very dangerous because that's something that can, completely bypass authentication and such. Fred will talk a little bit more about sessions later. So another thing that people do, please, let me repeat this, please, 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 never do this. Client-side authentication. Don't put your username and password in your JavaScript source files, because I can see that. Oh, John does that. All right, everyone, John does that, so everyone can go look. Everyone can go bypass authentication on his sites. But yeah, so this is something that happens commonly for like really small projects that no one ever going to interact with, and it's not bad. If it's something local, it's not going to be out to the public. You can do this if it's just something you want to get practice with. You can do this in your code. Highly unrecommended because JavaScript source files are sent to the client when you go to the website. So we can browse the source files and see your authentication details. Another thing, outdated NPM packages. So this is Node Package Manager. So when you're using Node.js or something that's that uses Node.js to compile, such as React or Angular, if you have outdated packages, a lot of times they have vulnerabilities that have been discovered in them. And the thing is, these vulnerabilities are often public. Now, one nice thing is if you have a Node project and you host it on GitHub, and you have your code uploaded there, GitHub has something called Dependabot built in, and it will automatically detect when vulnerabilities are in your Node packages and you're using that vulnerable version. It will send you an email. I get a lot of these emails from my old projects. I really don't care because they're not used anymore. But that is a really cool feature. Hey, John, you use local auth, John. All right, cores. This is, yeah, honestly, like full stack devs, we hate cores. Honestly, frick cores. It is like the most frustrating thing you'll ever run into in web dev if you're doing full stack. Basically, the idea behind cores is we only want to have those HTTP requests come from where we want them to. So we don't want, let's say we're requesting to our private database web server. We don't want youtube.com to be asking our web server for some private information. That's kind of sus. Like, hey, I don't know why YouTube wants to log into my auth server. So there's a header in HTTP requests. So there's a bunch of different headers you can set, and these are just values that get sent along with your actual request. So basically what CORS does is it's there to check the safety of any pre-flighted request. And it does this through something called access control allow origin. There's a few others that it checks, but this is the big main one. And you can specify an asterisk, which is a wildcard, and it will allow anyone to contact your web server and ask for information. But you might ask, what's a pre-flighted request? Well, CORS requests are broken up into two groups. They're simple requests. These you do not need to worry about CORS for. because these are things that are relatively safe and shouldn't be interacting with anything unless you like actively made your server really jank. So these are different content types that can be allowed in a simple request. So if we're just requesting plain text, right, like an HTML file, that's nothing, that's fine. HTML is static, we can do that. If we're sending or requesting form data, that's fine. We don't need to worry about cores. You know, we're sending from a form on our website. And then URL encoded form data, that I don't know that that's actually used a lot commonly today. Someone can correct me if I'm wrong. And the biggest thing is that you can't have any custom headers set in your request. This is something that I've run into and I got frustrated and it took me forever to figure out, but apparently you cannot have any custom headers. So typically custom headers will start with an X and a dash and then whatever your custom header name is. This is any information you want to specify to be able to send with your request for your specific application. However, if you do set a custom header or some other things, you will run into what's called a pre-flighted request. Now this does check for cores. What it does is your browser will automatically flag this. It'll say, hey, whoa, we can't just send a simple request. So it will send what's called an options packet on a HTTP packet. And we described that earlier in all the different methods. And what this does is it'll say, hey, what can I do with this server? And the server will say, well, it will return an error if you're not allowed to access it with your domain, your origin, or it will say, oh yeah, you're allowed. These are all the different methods you can use, and you can go ahead. And your browser will fail automatically if your request doesn't match up quite right. And it will spit out this lovely cores error, which is you're going to see a lot if you do full stack development. Another thing, credentials and authorization. It got covered up a little bit by the our camera view a little bit, but it says access control allow credentials true. So if you're passing any credentials for authentication, you need to have this header set because your browser will automatically strip that to protect against this kind of stuff. So there's a lot of misconfigurations that can happen with cores. Like I said, access control, allow origin, asterisk, wildcard. It allows everything. That's bad. We can use cross-site scripting to get into our backend. That's not good. So malicious sites can use your browser to fetch your personal information from other sites. And this is a common configuration for development. So if we just need to get it up so that we can start testing the front end. Just throw an asterisk in there, it's fine. Another one is allowing partially validated origins. So this is common if you have subdomains on your, and you need to allow all subdomains to access the backend. Well, the thing is, if your allowed origin is requester.com, well then I can just register a domain attackerrequester.com and it will be allowed, and then all of a sudden I can now access your backend. Again, you can use cross-site scripting from a valid origin. So if you're able to do some script injection on a valid origin and then request to the backend, well, there we go. We can use the JS Fetch API, check MDN for more, to make requests to our backend and get some personal information.
Talking about browser people using the browser to get PII, basically with cross-site request forgery, an attacker causes a victim to make a request from a site A, which is their malicious site, to site B, and then using that information, they modify something on site B. For example, as you can see in the little picture in the corner, basically the victim logs into their bank account on site B, and then they access site A, And what site A does is uses the cookie from site B to basically send a request. And as long as there's some type of form on the site and there's no protection on it, basically they can send themselves money, and yeah, basically that. And for this to work, site B must not have any protection, CSRF protections, which we'll talk in the next slide. And it must have a URL which causes an action to happen, such as transferring funds. The attacker also needs to know all the values for the URL to be able to pass it in correctly. And the victim must access site A after they logged into site B. And yeah, that's a little bit cut off, but yeah. So how to stop the attacks? Not that hard. So first thing is you would check the headers so that the origin or the referrer matched what your actual site is. And then you would have tokens in your form. So you could either do it via the cookie. So you would have both the cookie and the request body have some type of random value that's being tracked, and you could verify it that way. Or what you probably see more often is there is usually a hidden value in a form, and it has a random generated token in it. And once the form is sent to the backend validates that token to make sure that it is a valid form request. Let's talk about authentication then. So basically, authentication is used to verify if you should have access to a resource. So it's username and password, and usually some type of role. It should be handled by the application backend, not the front end, like Bradley said earlier. Don't do client-side authentication. And it's usually backed by some type of database to store the credentials and just verify sessions things. And there's usually 3 ways of doing this with HTTP parameters, the authorization header, and authentication cookies. So with HTTP parameters, you could either send via get parameters or post parameters. Never send it via get parameters, because those are basically just your URL. So if someone's sniffing traffic, they can just kind of see it. So don't use get parameters to send any type of real confidential information. Post parameters are better than the get parameters, since they're not right there. But it also requires the front end to keep track of the tokens. And also, you can only send post parameters with a post request, so it's not valid for the other requests, usually get requests, which you normally do. Another thing you can do are authorization headers. Basically, it's a header that's sent with it would be a header that is sent with your HTTP request, and it has some type of token in it, and the backend uses that to validate whether it is a valid session or login. And the caveat is it has to be tracked by the front end and make sure that it's sent all the time. Personally, what I think the best is the authentication cookies. So these are usually set by the server, and when you send the post request to log in, the server sends back a request to the front end with the set cookies header and sets the cookies. The nice thing about cookies is you could basically specify when they expire, for what domain they're valid for, if they could be modified or read by the JavaScript, and if they should only be valid for domains with HTTPS. So using that, it limits what a person can do with the cookies, and it's a little bit more secure in my opinion. And then sessions, what are they? Basically, they're the user status while they're interacting with a website. Usually, it's the state that's tracked by the front end, and that can be sent to the back end when it's necessary. But if anything in the session is used in the back end, always make sure to verify it with some second-hand truth to make sure that it's valid. Because, for example, if you have in an e-commerce store, usually this is used to keep track of a shopping cart state. So, and if in that shopping cart they have like the price of an item, and if you're just going off of that session state, if someone makes the price $0 and you don't validate that, well, then they might be buying something for completely free, which is never a good thing. And sessions are usually based like user login. So once you log in, you get your cookie, and then basically it uses that to keep track of your session while you're using the application. And SQL injections, you've probably heard a bunch about these. It's always hear about it. Basically, what it comes down to, sanitize your input. Because as long as you sanitize your input on the front end and the back end, you don't really have to worry about it, because there's no way you could attacker can escape your escape and actually run malicious SQL injections. And an example is if you're running raw SQL injections on the back end and you just have plain user input like added in, you can see if someone does colon or 1 equals 1, semicolon x hashtag. Basically, what ends up happening is they escape from the query that you made, and using that or 1 equals 1, whatever that query is, it validates. So if you're using that type of query for logging in, then basically someone gets access to the application, which you probably didn't want to do. But if you're trying to exploit this type of vulnerability, then what you would have to do, is verify the type of database they're using at the backend and the version that it's running, because different backends and different versions have different escape carry, different vulnerabilities, and it also depends what they're using for the front end, which would make the backend vulnerable to this stuff. It becomes a lot, so some existing tools such as SQL Map or JSQL Injections basically automate the process for you by using the different things, and personally, it's a lot easier using that than trying to manually figure it out.
All right. So local file inclusion, this is something that's actually popped up in a few of the demo challenges. So the basic idea behind this is, PHP. Nobody likes it, but the real facts of it is that it's still out there everywhere. A lot of people are still writing it to support older basically the idea is that people are still using it to support older applications, rather than just rewriting them from the ground up, because that's expensive. So within PHP, we can do a few things to just grab local files. And that makes things like CMS or content management systems really easy. Things like WordPress, things like basically any other CMS you can think of that runs on PHP, it probably uses some type of file inclusion. Who is it? Okay. All right. So basically the idea is that if we have different pages on our website, right? Let's say a home page, and then we have a shop page. Well, we can just include those in different files, and then we can redirect everyone to a single web page, index.php. But then we can specify exactly what file we're viewing. So let's say we're viewing home.php or shop.php. Well, it's just going to go grab that file and serve that content. But the problem is, if we don't sanitize this, if we don't make sure that we're only viewing files that we should be, we can do things like, what if we wanted to just say, oh yeah, the page we're looking for is Etsy password, like or sometimes depending on the way it's working, you may need to do a relative path or an absolute path. But we can do things like that. And if we have a file upload on the website, and we know where those files are being stored on the server, we can upload a reverse shell, and we can use PHP reverse shell because our web server already knows how to talk PHP. So we upload a PHP reverse shell. We figure out where the files are saved. We then request that file through our local file inclusion, and boom, you have a running remote shell. Now you have access into the server. Input sanitization. Fred mentioned this earlier. This is something that is really big in front-end development. Basically, expect any untrusted data to be malicious. All right. Oh, we have a question. It's funny. It has iFunny watermarks. It's funny. Trust me. Haha. Laugh. I don't hear people laughing. So, okay, so you basically expect any untrusted data to be malicious. Untrusted data is something that the user is inputting, right? Anything that's being sent that you're not generating or your applications are not generating themselves. So we can always assume that they're going to try and break our application. So there's three main different methods we can do to sanitize our inputs. We can escape our inputs, which essentially is like inserting backslashes and or whatever escape character your language uses. We need to escape things like, the greater than less than sign that's used for HTML tags, question marks, quotes, things like that. Anything that can be used to break out of any input and execute code on our server, we don't want that. We want to escape those. Another thing we could do is just validate. So on the front end, plus you can do it on the back end just to be double sure. We can make sure that our input is what we expect it to be. So we can either blacklist our characters like above. We can say we don't want any of these characters in there. There shouldn't be any of those in a username. We don't want that. We don't allow that. But the thing is, you need to make sure that you get all of the specified characters. Or you could do whitelisting through things like regex. You could just allow like alphanumeric and maybe just numbers. You can allow whatever characters you want, but only the characters that are not going to be dangerous. Another thing you can do is sanitizing. Now, if you're using some form of JavaScript on your front end, there's a lot of libraries that do this for you. I'm sure there's libraries for your respective language out there. Basically, it takes any input that the user is giving, and it's going to look for anything that's sus. Like, it's going to say, oh, hey, they're trying to escape out of here. They're trying to do a SQL injection. Nah, we're just going to cut that out of there. So this is actually like kind of like dynamic analysis of what the user is inputting, and before it sends it to the back end and or before it executes the code in the back end, it's going to sanitize and make sure there's nothing dangerous in there. Web shells. So this is something I talked about earlier, where we could upload a reverse shell. So basically, web shells can provide persistence, privilege escalation, or they can also, be like zombies or botnet. And so basically, this is post-exploitation. So as soon as you find a vulnerability or an exploit, this is something that you would upload as a payload to a server, so that way you have persistence, you have inside access. So first, we need something like a SQL injection or remote file inclusion, which is another method of local file inclusion, or cross-site scripting. Somehow, we can get that file uploaded. Yes, even the meme is educational. You can take PHP reverse shells, change the content type, change the magic bytes, change the file extension. Sometimes even changing the file extension works, and then you can still render it as PHP. Demos. So there's a ton of different kinds of of web shells that are out there. Lots of them are built into Kali. So if you boot up a Kali VM, they're going to be right in there for you. Or you can just use like my favorite cheat sheet. This website, slides will be posted. That's fine. You can go there, and I mean they're there for all kinds of languages: PHP, JavaScript, Golang. Yeah, there's even an awk web shell. So I mean, there's tons of different stuff that you can do to get inside access with web shells.
So let's finish this off with just talking about some tools for web analysis. So there's Burp Suite, which is uses multiple tools to accomplish the end goal of analyzing a web application, finding the security vulnerabilities for it, and then exploiting those, and then making you a nice, pretty report at the end. It's pretty dope. And it has a lot of features, though there's different ones. So there's like a free and community edition, but then there's also the premium and the enterprise version of it, which just unlocks more and just lets you do more. And then there is Zap, which is the Z attack proxy, and it's pretty easy to use as a penetration testing tool, and just to do a quick scan to see if there are any type of vulnerabilities in your application, just like quick over. And then there is ReconNG, which is a tool written in Python, and it's kind of like Metasploit, though only for the web, and it's not for breaking anything really. It's more just for reconnaissance and figuring out issues, figuring out possible vulnerabilities. And then there is the man-in-the-middle proxy, which is a console interface, which basically you set that as your proxy and allows you to inspect all requests being sent to and from a PC. So even if it's a HTTP request, it doesn't really care as long as you have it set up. And Burp Suite also does have this functionality. So what you would do with Burp Suite is you would basically set it as your proxy, and any connections being sent back and forth between your PC and whatever server, it would intercept, and then you can do things like analyze or change the different things that are sent, such as get or post parameters, as I talked about earlier, and then basically just break stuff. And it's important to remember that while these tools exist and they're automated, they don't do everything for you. They're there to help you, not to do your pen testing for you. And yeah.
I just want to say something real quick. You out there on stream, on internet land, all right? You need to do the demos. They're really fun, and I do them all the time, and they're really fun, and I learn a lot. You need to do them, and try and catch me on the leaderboard. Come on. Let's go. Let's go.
Also, if people might be interested, next week during research, we may or may not be talking about the game that we made for ISTS. So if you're interested about that, tune in, and yeah.
Thank you. There's a question.